All right, so here's your Quiz 7 study guide. And problem number 1. Basically, the question says you're given side lengths and you're asked to classify as acute, obtuse, or right. And then you're given side lengths. And we get a 17, 26, and a 36. All right, so based on, if you subtract 26 minus 17, you get 9. And if you add 26 to 17, you probably get like 43. So your range of values is between 9 and 43, and 36 is in that range. So you do have a triangle here. So then we're going to take 17 squared plus 26 squared and compare it to 36 squared. So 17x squared plus 26x squared, that's 965. And then 36 squared is equal to 1296. So our a squared plus our b squared is less than c squared. So when that is the case, what kind of triangle do we have? Obtuse, good. And then problem number 1 is like that. Number 5 is like that as well. Number 5, the numbers that you're given are 9, 7, and 12. All right, 9 minus 7 is 2. 9 plus 7 is 16. So your range of values for the third side is between 2 and 16. So this 12 does work. So we go 9 squared plus 7 squared and compare it to 12 squared. We get 130 on the left. We get 144 on the right. We're less than, again, our a squared plus our b squared is less than c squared. So that's obtuse. Number 8 is the same format, so let's take a look at it. Our 3 side lengths are 16, 63, and 64. 63 minus 16 is 47. And 63 plus 16 is 79. So the 64 is between those two numbers, so you do have a triangle. So 16 squared plus 63 squared compared to 64 squared. So I get a 4225 on the left, a 4096 on the right. So our a squared plus b squared is greater than c squared. That's an acute triangle. All right, and there's even another one on here, number 9. 30, 98, and 103. So if we take 98 minus 30, that's 68. And if we take 30 plus 98, that's 128. 103 is between those two values. So we do have a triangle. So we check 30 squared plus 98 squared and compare it to 103 squared. $10,504. $10,609. $10,504 is less than 10,609. So a squared plus b squared less than c squared. Obtuse again. What do they have to be for it to be a right triangle? They got to be equal to each other. Good. So that should be 4 easy points in your quiz tomorrow, right? Okay. So then we've got problem number 2, which you're asked to find the missing side. In simplest radical form. And here's our triangle. So I'm going to label these sides. The two sides that form the 90 are A and B. We're looking for the hypotenuse, side C. 12 squared plus 5 squared equals C squared. And our 12 squared plus 5 squared is 169. We're going to find the square root of each side. And 169 is a perfect square, so 13 is equal to C. Number 3, same instructions. Side lengths, we have a hypotenuse that's 13 and one of the legs that's 12. So I'm labeling the two sides that form the 90 as A and B. The hypotenuse is always C. So now we've got A squared plus 12 squared equals 13 squared. So I'm going to subtract 12 squared from each side. And A squared is equal to 25. And the square root of each side will give us an A that's equal to 5. Number 6, we go to a triangle where you're asked to find the length of the leg. So here's what you're given. This is from yesterday's lesson. Remember yesterday we said that in a 90-degree triangle, if one acute angle is 45 degrees and the other acute angle is 45 degrees. and the sides are congruent. So we can call them L. And we said yesterday that a leg in a 45, 45, 90 triangle, a leg is equal to the hypotenuse divided by the square root of 2. So a radical in the denominator, we're going to rationalize the denominator. So we're multiplying both the numerator and the denominator by square root of 2. In the numerator, we get 26, radical 2. In the denominator, the square root of 2 times the square root of 2 equals the square root of 4, and the square root of 4 equals 2. Now, this 2 goes into itself once, and it goes into 26 13 times. So in simplest radical form, the length of these legs is 13 radical 2. Number 11. We're finding the missing side again. (14) and 11. Labeling the sides A, B, and C. So 11 squared plus B squared equals 14 squared. Subtract 11 squared from each side. B squared equals 75. Now, I'm going to square root each side. So the square root of B squared is equal to B. And we've got radical 75 on the right. It's not a perfect square, so we have to simplify it. 75, the square root of 75 is equal to the square root of 25 times the square root of 3. The square root of 25 is equal to 5. So our B is equal to 5 radical 3. Number 12. We're given both the legs, 2 and 15. Labeling again, A, B, and C. So 2 squared plus 15 squared equals C squared. So 229 equals C squared. We're going to find the square root of each side. So the square root of C squared equals C. And we're looking for perfect squares that go into 229. (225) won't go evenly though, will it? No, we're looking for perfect squares that go into 229 evenly. So I've divided it by everything up to, let's see, 229 divided by 36. 49. 64. What's after 64? 81. Hundred doesn't go. 121 won't go. No, there's no perfect squares that go into 229 evenly. So this just stays radical 229. Number 13, we're back to a 45, 45, 90 triangle. You're given the hypotenuse, they're calling the leg x. So x is equal to 7 divided by square root of 2. We're going to rationalize the denominator. So in the numerator, we get 7 radical 2. In the denominator, we get square root of 2 times square root of 2 is the square root of 4, which is equal to 2. So here's your simplest radical form. Number 14. We've got a 45-degree angle down here. We got one leg is a 9, the hypotenuse is x, and the other leg is a y. So our x is equal to one of the legs times radical 2. And in a 45, 45, 90 right triangle, the legs are congruent to each other. So y is equal to 9. All right, and then we've got a couple questions left here. We got problem number 4. Quilt squares are cut on a diagonal. To form triangles. The hypotenuse is 20. What is the side of each piece? So exactly what they say, quilt squares. So if you got a square, all the sides are the same, right? Well, if we cut this thing in half, we've got a 90-degree angle up here. We got a 90-degree angle in each corner. And if we cut this square in half, we created a 45, 45, 90 with 2 congruent legs. And now a hypotenuse that's 20. So it's just a matter of taking the words and drawing the picture. So our L is equal to square root of 20 divided by square root of 2. No, not the square root of 20, just 20, I'm sorry. 20 divided by the square root of 2. So we've got to rationalize this denominator. So we get 20 radical 2 over 2. The 2 goes into itself once, and it goes into the 20 10 times. So our simplest radical form is just 10 radical 2. Problem number 7 on the study guide says the area of a square garden is 242 meters squared. How long is the diagonal? All right, so you've got a square. The area of the square equals 242. The formula for area of a square is one side squared. And here's one of the sides. But all the sides are the same, aren't they? And all the angles are 90 degrees. How long is the diagonal? Here's the diagonal. We're dealing with another 45, 45 right triangle. So we need to find this side length first. So if area equals 242 and area equals side squared, then 242 equals a side squared. So if we find the square root of each side, then radical 242 equals one of the sides. So let's simplify this 242. Hmm. 121 goes twice. So this 242 equals square root of 121 times square root of 2. Square root of 121 is 11. So this side length equals 11 radical 2. One of the sides. Both of the sides. All of the sides are equal to 11 radical 2. So 11 radical 2. But we need the hypotenuse. We need this diagonal. So the diagonal, I'll call it D. The diagonal of this triangle is going to be equal to one of the sides (11 radical 2) times square root of 2. 11 radical 2 times the square root of 2 equals 11 radical 4. The square root of 4 is equal to 2. So our diagonal is equal to 11 times 2, which is 22. And then problem number 10 says that triangle ABC has sides 6, 8, and 10. Do the side lengths form a Pythagorean triple? Remember a Pythagorean triple? A set of three whole numbers such that a squared plus b squared equals c squared, where a and b are always your smallest two. So what they're asking you here is, does 6 squared plus 8 squared equal 10 squared? Question. Just type it in. All right, your a squared plus your b squared equals 100. Your 10 squared equals 100. So yes, your a squared plus your b squared equals your c squared. Do they form a Pythagorean triple? Yes. A squared plus b squared equals c squared. All right, so that completes your study guide for quiz 7.